Okay, good morning, first period. I'm not sure if the sub got this to work for you guys, but if not, I posted this on Google Classroom, so you're either watching it with the sub or Google Classroom, just to go through 3.3 notes with you guys. Again, we skipped 3.2. I'll go over that on Tuesday because it really deals with 3.1 and it deals with a little more complicated than 3.1, and I want to be the one teaching you. So get out your notes, turn to 3.3. Should look like this, skip 3.2 right now, and turn to there. Okay, and we're just going to go through some things. First of all, we're going to go through some negatives and positives. So we all know that all sad turtles cry. Okay, so we know that sine is positive in these two quadrants. So we know, I know by heart that the sine of 30 is 1/2. So the sine of 30, which is this is 30, is 1/2. Because that point is radical 3 over 2, 1/2. What is the sine of negative 30? So if I'm going backwards, here, what is the sine of that? Well, think about it. That's going to be the same reference angle, but we are in quadrant 4, so the sine of 30 would be negative 1/2. So it changes to a negative, a reflection across the x-axis. Well, let's see what does that do with cosine. So with cosine, all sad turtles cry. Okay, so on cosine, we are dealing with 30 degrees, same point, radical 3 over 2, 1/2. But if we go to negative 30 degrees, it's the exact same coordinate on your unit circle. It doesn't change to the opposite sign because in quadrant 4, cosine is positive, so it stays positive 1/2. So cosine of 30 and cosine of negative 130, is both positive 1/2. Well, what about tangent of 30? Well, outside tangent of 30 is radical 3 over 3. But now if you go over here, because tangent's negative, this becomes negative radical 3 over 3. So it changes. Positive radical 3 over 3, negative radical 3 over 3. So if you notice, some things change signs when you reflect it across the x-axis and some things don't. Okay, it would be the same thing if I was doing in quadrant 3. I didn't give you an example in quadrant 3, but if I was in quadrant 3 and I did 150, sine of 150 is also a positive 1/2, and if I did a negative 150, it would be here, it'd be negative 1/2. Okay, so we're going to talk about when does it goes positive, when goes negative. And if we did cosine, they're both going to be negative here, because cosine is negative in both these quadrants. So to put that into a shorter thing, you're going to see this at the top of your notes. Cosine of a negative angle and cosine of a positive angle are exactly the same. They're called even. I think of even as the same. Doesn't change anything. So the cosine of 30 and the cosine of negative 30 and the cosine of negative 30 are both the same. They're both radical 3 over 2. They didn't change at all. Same thing for secant because it's a reciprocal. It would not change. But sine and tangent, if you remember, it flipped. So let me go back real quick. So sine, oops, sorry, I have to go back to. So sine, positive 1/2, negative 1/2, because we flipped it over the x-axis and the quadrants changed the sign. Same thing for tangent. So we call things like that odd. Odd means it turns to the opposite side. So think of odd with an O and then opposite. So they turn to the opposite sign. I'm going to enlarge this a little bit. Hopefully I don't lose you guys. Okay? And the reciprocal is the same. So if I asked you what the sine of 30 is, but the sine of negative 30 is negative 1/2. And it's not because it's a negative angle, it's just because what quadrant we're in. Okay, so these examples I'm going to show you are very similar to what you're going to see on the worksheet. Don't overthink this. It's very simple. So here's your first example. They're giving you this, that the cosine of some negative angle is negative radical 3 over 7. Okay, cosine is the only one that is even. So it stays the same sign when you become a positive angle. Because these are going to stay the same sign, the answer to this is also negative 3 over 7. And then secant, make sure you look at the negative. The secant's the reciprocal of that one, which doesn't really matter, but it's 7 over negative 3. It stays the same sign. Don't overthink it. You're just thinking, is the reciprocal going to be, reciprocal, and you're also thinking, is it going to change the sign or is it going to be the same sign? Cosine's the only one that stays the same. If you look at this example, that's negative 7 over 10. This is an odd function. It changes sign. So if we are at one angle and it's negative 7 over 10, this one's going to be positive 7 over 10. Because sine is always turns the opposite. So as soon as you go to a different quadrant, it turns the opposite. And then cosecant, make sure you're flipping the one that's the same angle, would be positive 10 over 7. So they're going to change to the opposite sign because they're called odd functions. Again, it's because when you're here, this is all, and when you're here, this is not all. That's going to switch. Okay, so that's like part of the homework. Super easy on your worksheet. The next part is we've talked about these reciprocals. We've had these in our notes before in chapter 1. Same thing, the ones that are new are these. These are also new, but this we will talk about on the block day. So you'll see that come up. That actually isn't in your notes, it's just in mine. But that, we're not dealing with that till Thursday. But these are reciprocal, or quotient identities, sorry. Tangent is sine over cosine, because think about it. Tangent is y over x, sine is y, cosine is x, so it makes sense the tangent is y over x, sine over cosine. And then the cotangent is the reciprocal. We're going to use that a lot. Okay, so I like these. This is one of my favorite parts of trig. Don't ask me why. I think they're easy. I like these. So we are trying to simplify. All we're trying to simplify is we're trying to get the answer to be 0, 1, or one trig function in the most case. And what you want to do is try to change everything to sines and cosines. So the first thing I'm going to do is I want to change everything to sine and cosine. Well, this is already a cosine, so I'm not going to do that. So I'm going to change tangent. Again, tangent is sine over cosine. So that is what tangent is equal to. I'm going to leave this as cosine. I like to put a 1 underneath it. And now all I do is simplify. So I'm going to cross cancel. And I'm left with sine over 1 or sine. So that's what's simplified. So if you took any tangent function and multiply by any cosine function, you get the same as the sine function, which is really interesting. Okay. Just to show you, tangent of 30 degrees is radical 3 over 3. Cosine of 30 degrees is radical 3 over 2. If you multiply it across, that would be 3 over 6, which is 1/2. And the sine of 30 degrees equals 1/2. So kind of interesting little pattern. Okay, don't really need to know that part. You just need to know how to simplify. Same thing on the next one. So you see there's a sine. Change everything to sines and cosines. That one I'm going to leave. So I'm going to leave it as sine over 1. I need to change that. So I'm going to use reciprocals. Remember, s's go with c's. So secant, from our last little slide here, secant is 1 over cosine. So I'm going to change my secant to 1 over cosine. And then cotangent, there's two things you can use for cotangent. So I'm going to go back to the last slide again. So I can use this, which really doesn't help me because it doesn't make everything sine or cosine, or I can use this. Cotangent is cosine over sine. So I'm going to replace cotangent with cosine over sine. Now I have 3 fractions. I'm going to reduce these 3 fractions. I can cross cancel anywhere. You'll notice the cosines cross cancel, the sines cross cancel. These are 1, 1, 1, 1. You get 1 over 1, which is equal to 1. So if you multiply the sine of 30 times the secant of 30 times the cotangent of 30, actually all cancel out and be 1. Okay, so we're going to try a couple more. I think it's fun to cross cancel, so that's kind of, I guess, why I like these. So on number 3, we got some squared. Okay, so Again, don't try to overthink it. Replace everything with sines and cosines. So I'm going to leave that cosine the same. I'm going to replace this, remember S's go with C's, with 1 over cosine squared. Because if it's secant squared, it has to be cosine squared. I like to put a 1 underneath. And now I'm on the denominator. Again, tangent just is the reciprocal of cotangent, but replace it with sine over cosine. So on your notes, it's a big one. Tangent equals sine over cosine. Okay, so now simplify the numerator. So the cosine cancels. I still have 1 cosine left. So I have 1 cosine over sine cosine. And then keep, flip, change. So keep your numerator. Flip the denominator and change it to a multiplication problem. These are going to cancel out. You're going to get 1 over sine. Now that is not our complete answer. We don't want to leave things as a reciprocal function. We want to leave things as 1. And remember, S's go with C's, so 1 over sine is the same as cosecant. And that's as simple as we can get it. Really not a shorter way to do that. Not too much. Okay, so we got one more where we got to do this. A lot of this chapter is this, but doing more complicated. So it's a very good and just a basic introduction to it. So this last one, it tells you to prove. So it tells you the answer is 1. You have to prove it. So you know this is going to be the answer. So you're not going to fool with that. You're just going to look at this side and you're going to show how it is. And it says use trig identities to transfer one side of the equation to the other side. So we're trying to transform this one to be 1. Again, make S's everything cosine and sine. So we'll leave that cosine there. Put a 1 underneath it. Secant is a reciprocal of cosine. These cross cancel. You get 1 over 1 or 1. So the answer they told you is 1. You are proving, so you're basically showing the work. So it's nice. The word answer's there. I just got to show it. Okay, last thing. So that's kind of the meat of everything is really this part, but you have some other odd and even identities. Last part are called complementary cofunctions. So if you guys remember complementary, it's 2 angles whose sum equals 90. Supplementary is 180, complementary is 90. So if you really thought about it, the sine of 30 is 1/2, and the cosine of 60 is also 1/2. They have the same answer. So does a lot of different things. These two add up to be 90. So the sine of 30 is the same as the cosine of 90 minus 60. So the sine of 30 is the same as the cosine of 90 minus 30, which equals 60. Same thing for cosine. So these are called cofunctions because they're complementary. So sine and cosine are cofunctions. Tangent and cotangent are cofunctions, and secant and cosecant. And the secant and cosecant should make sense because it's reciprocal, and then tangent and cotangent. So you might have seen like the tangent of 30 equals radical 3 over 3, and then the cotangent of 30 actually equals 60 equals radical 3 over 3. They're the same. Okay? You're also going to see pi's in it sometimes. So instead of 90, they'll say pi over 2. So how to use that? This is going to come later on, but this is the same exact slide, but instead of 90, I have pi over 2 because 90 is pi over 2. So how to use that to simplify things? Probably the easiest part of your homework is we're going to simplify this. So I'm going to find the cofunction of sine of 40. I don't know what the sine of 40 is, but I do know that sine and cosine are cofunctions. So I know the sine of 40 is equal to the cosine of 90 minus 40. So it's equal to the cosine of 50 degrees. Because sine and cosine are cofunctions. Cotangent and tangent are cofunctions. So I know cotangent is 70, then I know the tangent is the same as the complementary angle to that. So it's the same as the tangent of 20 degrees. So if you put in the calculator cotangent 70 and tangent 20, get the same answer. and S's go with C's, but so these are cofunctions, so that means their reciprocal is a cofunction. Again, if the secant of 80 degrees would be the same as the cosecant of 90 minus 80, which is 10 degrees. Oops, sorry, 10 degrees. Can't get any easier than that. Okay, so your worksheet, very similar. Okay, I'm going to grab a worksheet. Sorry, hold on one second. Maybe grab a worksheet. Okay, so, sorry that took me a while. So, on your worksheet, you're going to notice that the first couple are like the first examples. All you have to do is it going to change to be the same sign or is it going to be opposite sign? Sine's an odd function, these will become the opposite. Cosine's an even, it's going to stay the same sign. You're going to fill these blanks in from the notes. If you notice, these all have ones over it, so you're putting just one, either sine or cosine or whatever underneath it. Here you're writing the quotient identities. This, I'm actually going to take off. We will talk about that next time. Sorry, we didn't do that on the notes right now, so I'm going to take that off. And then these are the last thing I did. And then these are just doing what I did in the notes on 1, 2, 3, and 4. And look it, no back. Woo! Super easy. You should be able to get this done, and I shouldn't have too many questions. Okay, hope you guys have a good day. Miss you guys. See you guys on Tuesday. Thank you.